So today we're talking about rate of change and slope. I know you talked about slope last year, maybe even the year before, um, but our first blank is going to be rate of change. Rate of change is just another way of saying slope. It's the rate that something changes. Slope is important. You will also even do it in calculus, except in calculus it's going to be called derivative. So the rate of change, I give you a formula here. It's the change in y over the change in x. Sometimes you will see that written as y2 minus y1 equals x2 minus x1. So this just means your second y minus your first y over your second x minus your first x. And slope is called m. I don't know why they picked m, they just did. So the first two examples, we're just going to find the rate of change. You can do this by picking any two rows. So if I pick this row and this row, that gives me the point 1, 7, and 3, 11. So we're going to subtract our second y. So this is x1, this is y1, this is x2, this is y2. So subtract your y2, 11, minus your y1, 7, because that's just your second y. So the y from your second coordinate minus the y from your first coordinate over the x from your second coordinate minus the x from your first coordinate. If for some reason you subtract them in the other order, that is perfectly fine. So if you did 7 minus 11 over 1 minus 3, that is fine. Just make sure you don't do 7 minus 11 over 3 minus 1. So whatever coordinate you start with your very first number is the coordinate you need to start with for your denominator as well. So notice 11 and 3 come from the same coordinate and 7 and 1 come from the same coordinate. Anyway, 11 minus 7 is 4, 3 minus 1 is 2, 4 over 2 is 2. So the slope is 2. For number 2, this is going to be my x column and this is my y column because this is money. And money always goes first because we always want to figure out the price per something. We never really want to figure out how much of something we're going to get per dollar. It's always how much am I going to spend for one of something. So I'm just going to pick the first two rows again. So I'm picking 0, 0. So that's my x1 and my y1. And then I'm going to pick 76 and 2.40. So this is my x2 and my y2. Subtract your y's on top, so 2.40 minus 0, and your x's on bottom, 76 minus 0. So we get 2.40 over 76, and 2.40 divided by 76 is 0.03. So in the instructions it says explain the meaning for number 2. That just means it's going to be 3 cents per gallon. So that's all it means, 3 cents per gallon. Okay, going on to the next set of examples. Here we're given a graph and we want to find the slope. You can do this one in two ways. I know a lot of people from last year remembered rise over run, so that's one way. Another way is to pick any 2 points on my graph. So here I can pick 2, 5, and 0, negative 1, and just subtract them like I did with the first two examples. So subtract your y, it's negative 1 minus 5, over your x's, 0 minus 2. Negative 1 minus 5 is negative 6, 0 minus 2 is negative 2, and 6 divided by negative 2 is 3. So your slope is 3. But another way you can do this is start with any 2 points. So if I pick these 2 points again, go to the point on the left and figure out how many did I run. I ran 6, or rise, and then how many did I run? 2. So it's still 6 over 2, which is still 3. So that way was rise over run. Okay, number 2, they give me 2 points, so I can do it that way. 0, 7, and 4, 4. Subtract the y's on top, so 4 minus 7. Subtract your x's on bottom, 4 minus 0. 4 minus 7 is negative 3. 4 minus 0 is 4, so negative 3/4. And again, we can check that with rise over run. Take your 2 points, start with the point on the left, figure out how many did I rise. Well, I rose -3, and then I ran 4, so it's still -3 over 4. For number 3, again, pick any 2 points. I'm going to pick 0, 4, and 2, 4. Subtract your y's on top, 4 minus 4. Your x's on bottom, 2 minus 0, to get 0 over 2, and 0 divided by 2 is 0. So your slope is 0, and that's because you didn't rise any, you just ran. So since I didn't rise any, the slope is 0. It didn't go up or go down. For number 4, be careful with this one because some people think it's 0 as well, but it isn't. So pick 2 points again. I'm going to pick 2, 2, and 2, 3. Subtract your y's on top, 3 minus 2. Your x's on bottom, 2 minus 2, to get 1 over 0. Now you cannot do 1 divided by 0. You can do 0 divided by 1, but not 1 divided by 0. So if you have 0 in the denominator, that's going to be called undefined. A way to remember this is if I were to look at this graph, it is not a function. It does not pass the vertical line test or the pencil test. Since it's not a function, it's undefined. So just a way to remember it. Okay, we have 2 more problems on the back. Before we get to the 2 other problems, I wanted to show you these 2 pictures. Some people like visuals. So if your graph looks like this left eyebrow, it's a positive slope. If it looks like the right eyebrow, it's a negative slope. If it goes straight up and down to make your nose, it is undefined. If it goes straight left and right for the mouth, it's 0. And then also there's a trick with how do you write -0 and no slope. So negative slope, there's a slant going down with the letter N, 0 slope going left to right, and no slope up and down. Okay, the next 2 examples we're figuring out if these tables would be linear. When we do this, we need to make sure they are adding or subtracting the same number. I don't care about multiplying and dividing, I only care about adding and subtracting. You could do this where we figure out the slope between each 2 points, but there's a quicker way. If I look at my x's, 1 to 4, I added 3. 4 to 7, added 3. 7 to 10, added 3. 10 to 13, added 3. Since it's the same number every time, my x side is good. Now looking at my y's, -6 to -8, I subtracted 2. -8 to -10, subtracted 2. -10 to -12, subtracted 2. -12 to -14, subtracted 2. Same number on my y's, so my y's are good. Since both sides were good, that means it is linear. So yes, it is linear because we're going to say it has a constant rate of change, which just means that the rate at which it changed was always the same. And to be more specific here, the slope, or the rate of change, is going to be -2 over 3, because my y side was -2, my x side was 3. And we always put y on top. Okay. So again, you also could have just figured out the slope between all 2 points, but that takes a lot more time and effort, and this way works. So looking at number 2, -3 to -1, I added 2. -1 to 1, added 2. 1 to 3, I added 2. 3 to 5, I added 2. So my x side is good. Looking at my y's, 10 to 12, added 2. 12 to 16, I added 4. So that's already different, so it's going to be no. It is not linear because it doesn't have a constant rate of change. Okay, so if you have any questions, please let me know.